We talk a lot about cutting carbon emissions, and for good reason. But what if I told you that might not be enough anymore? What if the climate itself has started to, well, do some of the warming for us? Today, we're going to dig into why that's happening and look at some pretty radical ideas for not just slowing the problem down, but actually throwing it into reverse. So to really get why we need these new ideas, you have to understand the sheer scale of the problem. Get this number in your head. 36.8 billion tons. That's the record amount of CO2 we pumped into the atmosphere from fossil fuels and industry in 2023 alone, just 1 year. It's a mind-boggling number, and it shows we are still, unfortunately, heading in the wrong direction.
And if you thought that was a big number, this one is even more critical. 400 gigatons. You can think of this as our planet's entire remaining carbon budget, if we want to have a good shot at keeping warming to 1.5 degrees Celsius. At the rate we're going to blow through that entire budget in less than 10 years. The clock is absolutely ticking. We are about to seriously overdraw our global account.
Now, here's where it gets really tricky. It's not just about the stuff we're adding to the atmosphere anymore. See, the climate system itself has these built-in mechanisms that can actually speed up the warming all by themselves. They're called feedback loops.
So what on earth is a feedback loop? Well, it's simpler than it sounds. Think about your own body. When you get too hot, your brain gets that signal and tells you to sweat. The sweat cools you down, bringing your temperature back to normal. That's a stabilizing loop, a negative feedback loop. But with climate, some of these loops, they push things in the wrong direction.
And this is the absolute key. There are basically two flavors of these loops. You've got negative feedback loops, like the sweating example, that work to keep things in balance. They slow change down. But then you have positive feedback loops. They do the exact opposite. They accelerate change and create instability. And here's the really important part. When we're talking about climate change, positive does not mean good. It means bad. It means it's making the problem worse.
And this picture just lays it out perfectly. Okay, on the left, that's a positive or amplifying loop. More CO2 in the air warms things up. That warms the ocean. A warmer ocean, it turns out, is worse at absorbing CO2. So more CO2 stays in the atmosphere, which leads to more warming, and you see where this is going. It's a vicious cycle. On the right, though, is a potential negative loop. The idea is that warming could lead to more clouds, and those clouds could reflect sunlight back into space, creating a cooling effect. It's a balancing act.
This quote just sums it up perfectly, doesn't it? When you hear scientists talk about climate tipping points, this is often what they're referring to. They're talking about these positive feedback loops starting to run away, where the planet's own systems start working against us, speeding up the very problem we created.
So, let's connect the dots. Our carbon budget is almost gone, and the planet itself is starting to speed up its own warming. It's becoming really clear that just cutting our emissions, while totally essential, might not be enough anymore. This reality has forced a huge shift in strategy, which brings us to the big, flashing question. If we can't just turn off the tap and hope for the best, what other tools do we have? How do we start dealing with all the carbon that's already up there, especially when the Earth is getting less and less efficient at cleaning it up for us? And the answer might be found in a whole new field of tools called negative emission technologies. We just call them NETs for short. The key words here are active removal. This isn't about just producing less carbon. This is about building systems, both natural and technological, to physically pull existing carbon dioxide right back out of the sky. This is a massive paradigm shift. For decades, the entire conversation was about one thing: decarbonization. Stop making the mess. NETs add a second huge goal to the list: cleanup. It's kind of like we've not only decided to stop leaving the hose on in the basement, but we've also finally brought in some giant pumps to start draining the water that's already there.
Okay, so this whole idea of carbon removal sounds great, right? But what does it actually look like? How do we do it? Let's pop the hood and take a look at the toolkit.
The toolkit is amazingly diverse. You've got the natural stuff, like planting just massive forests, or improving how our soil can store carbon, sometimes with additives like biochar, which is a special kind of charcoal. But then you get into the really high-tech stuff. Things like BXCCS, where you grow plants, burn them for energy, but capture the CO2 before it escapes. And then there's direct air capture, which is basically giant machines with fans and filters that literally suck CO2 out of the ambient air. There are even ideas about grinding up certain rocks that absorb CO2 and a bunch of methods for helping the ocean soak up more carbon.
And we're gonna need a lot of it. The IPCC, the big UN climate science body, has run the models, and a lot of them show that to hit our targets, we need to be removing around 6 gigatons of CO2 every single year by 2050. Now, to put that into perspective, that's more than the entire United States emits in a year. So yeah, it's a colossal amount.
Of course, if this were easy, we'd be doing it already. And I have to be really clear here. These technologies are super promising, but they are not a silver bullet, not even close. They come with a whole list of massive, massive challenges.
Right? That's the obvious question. What's the catch? Why isn't every country building giant carbon-sucking vacuums right now? Well, the list of reasons is pretty long and pretty serious.
Let's just run through the big four. First, scalability. Can we actually build and deploy this stuff fast enough and at the planetary scale that's needed? Second, cost. This is incredibly expensive, and right now, there isn't really a business model. Who's going to pay for it? Third, energy. A lot of these technologies, especially direct air capture, need a staggering amount of energy to run, and that energy has to be clean or you're just defeating the purpose. And finally, governance. How do we track all this? How do we verify that a ton of CO2 removed in one country is a real ton? These are huge, unanswered questions.
And this brings us to what is maybe the most crucial takeaway of this whole explainer. Negative emission technologies can never, ever be an excuse to take our foot off the gas when it comes to cutting our emissions. They are a supplement, not a substitute. We still have to do the incredibly hard work of decarbonizing our entire economy. Nets are for dealing with the mess we've already made, the carbon we've already overdrawn from our budget.
So, we end up right back where we started. We are in a race against time. On one side, you have the planet's positive feedback loops threatening to push warming past our control. And on the other side, you have human ingenuity racing to build the tools we need to clean up our own mess. The defining question for our future might just be this one: can we innovate faster than the climate can accelerate?